I want to talk to you about something that's kind of subtle but very important. This problem obviously requires the law of cosines, and because there's no pairing that exists. So you would use the 54 here and the b, and you would be able to solve for b, basically using the law of cosines. Now, once you have that, you can jump over to the law of sines to use it, because now you have that beautiful pairing. The question becomes, what do I solve for next, and does it matter? It actually can matter. At this stage, you would always solve for the smallest angle. Now here's why. If one of the angles was, let's say, and B kind of looks that way, if one of those angles was obtuse, and you go about the business of solving for it, at some stage you might get, the sine of angle B equals 0 point, I don't know, some ratio, let's say. Now your calculator isn't smart enough to discern, is that ratio happening here, this opposite to this hypotenuse, or is it happening over here, this opposite to this hypotenuse? Now those two have very different answers, because one would be an acute angle and the other would be an obtuse angle of 180 minus that little angle. And so it would actually spit out the acute angle even though it might be the obtuse. Does that kind of make sense to you? So the way you avoid any concern about, whoa, is angle B obtuse or not, you solve for the next smallest side. Now the next smallest side, smallest angle, would be C, because it's opposite the 12. So it would be smaller than the one across from the 19, guaranteeing it has to be acute. Remember, the most obtuse angles you can get in one triangle is 1. So if you solve for the other small one, it's definitely not obtuse. So this is a way to guarantee that the law of sines won't confuse you or create an error. And once you get the second angle, you get the third angle and you're done.